In this video, we'll look at organic isomers. Isomers are molecules with the same molecular formula, but different chemical structures. Isomers can be placed in two broad categories. Structural isomers, where the connections between the atoms has changed, and spatial isomers, where the connections between the atoms are the same, but in spatial space, they are different. If we think about isomers, again, separating into structural and spatial, we can look at this flowchart. If we have a structural isomer, the connections between the atoms is not the same, these will be constitutional isomers. If we had 4 carbons in a straight chain, that would be one isomer. If we had those same 4 carbons, but now we have 3 carbons in a straight chain and 1 carbon attached to the middle, the connections between the atoms are not the same. These are constitutional isomers. With stereoisomers, those where we have different spatial arrangements but the same connections between atoms, we have enantiomers, which are optical isomers, and diastereomers. Enantiomers, optical isomers, we can think about a left hand and a right hand. All things being equal, these will be optical isomers. To have an optical isomer, I must have a chiral molecule. One way to have a chiral molecule is to have a carbon with 4 different things attached. We can visualize a generic carbon with A, B, C, and D attached. We can have 2 species that are mirror images of each other. Enantiomers will have a mirror image, and enantiomers are defined as 2 non-superimposable molecules that are mirror images. Diastereomers are also stereoisomers. You can have a diastereomer that is based on a cis-trans isomerization, where we have a component like a double bond where we cannot rotate the 2 groups. The cis and trans, cis being on the same side, trans being on the opposite side. If we think about a multiple bond, this is cis and trans. Conformers are actually rotations. We can have different conformations or different rotations. The thing about conformations is they are spatial arrangements, but they can be converted back and forth by just rotating around a bond. Let's look at some problems. Label the following pairs of isomers as constitutional, cis-trans, conformational, or optical isomers. In the first pair, we see that we have 5 carbons in a straight chain. Each carbon is connected to one other carbon. In the other structure, we see that we have 4 carbons in a straight chain and 1 carbon that's attached to the second carbon. That carbon has 3 connections to carbon. Therefore, the connections are different, and these will be constitutional isomers. There's a significant structural difference. We've changed the way the atoms are connected. Let's look at the next. Here we have a double bond species. When we have a double bond, we cannot rotate around that bond. That means that in the first case, where we have the chlorine facing up and the methyl facing down, there is no way to change that into the second object we have, where we have the chlorine going up and the methyl going up. The connections are the same. Each atom is connected to the same atoms. But where they are connected in space is different. Since we have the double bond, and we have, in the first case, opposite sides, trans, in the second case, same side, cis, this would be a cis-trans isomer. In the next one, you can see here that we have 2 molecules. All the connections are the same. And what's highlighted is the carbon in the middle that has 4 different groups attached. This is our hint that this is an optically active molecule. And this is a chiral. Chiral meaning hand, left and right. Notice that we have a mirror plane between these 2. Because these 2 are mirror images of each other, these are enantiomers. In the last case, again, notice that all of our connections are the same. So this is not going to be a structural isomer or a constitutional isomer. It looks like a cis-trans, but notice that we have a single bond. Because we have a single bond, we can rotate around that single bond, and we can convert the first conformation into the second. Now there's some energy to do this, to convert from one conformation to the other, But since we can convert, these are conformations. There are lots of isomers in organic chemistry. Carbon can make 4 bonds, and it makes very stable covalent bonds. Because of that, there are lots of different isomers. Some of them are easy to recognize by just trying to name the molecule, which almost always works, and others by just being observant. As you can see in the 2 diastereomers, conformations, and cis-trans isomers, it is also important to understand the bonding structure, that you cannot rotate a double bond, but you can rotate a single bond. Practice recognizing isomers and become confident.